we want to find the limit as x goes to infinity of sine x over x. As x goes to infinity, the denominator clearly goes to infinity, but the numerator does not have a limit. So the limit of the numerator doesn't exist. The sine curve oscillates between a height of 1 and minus 1. And as x goes to infinity, the curve does not head towards a particular height. There's no horizontal asymptote. It also does not go up to infinity or down to minus infinity. The sine of x limit at infinity does not exist due to the oscillation between two fixed heights, 1 and negative 1. That's a 1. Due to oscillation. And so this is not going to get us an answer. However, we probably suspect that the answer is 0, because if you have a fixed number, like 4 divided by infinity, that would be 0. And while the numerator is not a fixed number, it's just oscillating between two fixed numbers, negative 1 and 1. So we suspect that the answer is 0. But we can't be certain, and to determine that it is in fact 0, we use the Squeeze Theorem. So we want to say that the sine of x over x is between two other functions, and then we want to compute the limits of these functions, this one and this one. And if both of these limits are the same, then the Squeeze Theorem tells us that the function in the middle shares that common limit. So to construct such a compound inequality, we begin by using the fact that the sine of x is oscillating between two values. So we can write the sine of x is between negative 1 and 1, and that's true for all x. So that's the beginning of a compound inequality. Now we want to have in the middle, we want it to be the function that we see here, sine x over x. So we want to divide everything through by x. So divide by x. Now when you multiply or divide an inequality, both sides of an inequality, then you might have to change the direction of the inequality symbols. If the x is positive, then you leave the inequality symbols the way they are. But if the x is negative, you have to switch them. Well, in this example, x is heading towards positive infinity. So we can assume that x is positive. So dividing by x in all three members of this compound inequality, we will leave the sense of the inequality symbols, the direction, alone. So we will have sine x over x is between negative 1 over x and 1 over x. So there's our g1 of x, and there's our g2 of x, our bounding functions. Our function is between these two functions. Now we will compute the limit of each of those functions as x goes to infinity. So the limit as x goes to infinity of negative 1 over x, that would be 0, because we have negative 1 over infinity. And in a limit, when you have a number divided by infinity, that's going to give you 0. And similarly, the limit as x goes to infinity of 1 over x is 0. These two limits are the same, and so by the Squeeze Theorem, the quantity in the middle shares their common limit. So by the Squeeze Theorem, the limit as x goes to infinity of sine x over x must equal 0 as well.